simultaneously dying.
I would say they weigh about the same, dude, because that.
I do think they weigh the same, but now here's the interesting thing though. It's displacing more water because it sank all the way in. So the ice floats better than just regular water. So that's that neutral buoyancy thing I was talking about. So why is that?
Do they feel like they weigh the same when you hold them?
I feel like they weigh the same.
I think it's because there's air bubbles.
I think it's for whatever, when the ice forms, it gets voids, or I don't know.
You'd think ice would weigh more than water.
Well, yeah, but if it's the same amount of water, see, that's what we wanted.
It does weigh the same. It has a different mass.
Right.
This has less mass than that because there's air inside this.
It's affected mass. I guess it's equivalent. I would think it was equivalent mass because nothing's necessarily. Well, I mean the
mass and weight aren't necessarily the same thing.
It's true. And the properties have changed. So,
I mean, you can have a lump of pumice that big, and it could weigh less than a thing of lead that big,
and have an equivalent mass or equivalent volume. Yeah. Well, let's go with that. So we have equal volume. But since we can't actually test weight, then we're going to assume they're the same weight. But there's more distribution of water only because there's less buoyancy. But that's my question: is why is the so that just now we posited a new question. Yeah.
What's your new question?
So the ice seems to float better than an equivalent water balloon. So the water balloon achieves neutral buoyancy, but the ice floats higher. So it displaces less water. So why does the ice float higher?
Wait. In the same shape? It displaces less water.
The ice displaces less because it's floating higher up.
Even if you take the same amount of water and
watch, we got it marked right there. So this is about an equivalent water balloon. But here's the interesting. So you put the ice in, and see how much higher the ice floats? How much you've got sticking up out of it?
What do you mean by equivalent?
Okay. The ice is higher in the water. Okay, so it's displacing less water because it'll displace more. If I push it all the way down, it'll displace more. So it's displacing less. But when I put an equivalent water balloon in, watch what happens.
It only has a small surface area.
So the water balloon floats lower, or achieves equal buoyancy, I guess, neutral buoyancy, than the ice does.
Can I ask you a question?
Sure.
What do you think would happen if you took that balloon and froze it? Do you think that it would displace
that's what I want
the
to know.
same amount?
Well, I'm wondering if it'll float. What we really need to determine is whether it would float higher. Right. So if we freeze it, will it float up out of the water more?
Okay. That's a question. I would. That's a perfect question to capture.
I would think that if they weigh the same and we freeze this, it would be basically the same. I think the only difference would be like how many air bubbles are in it.
Well, yeah, but that's what I'm saying. And it's in a confined sphere. It's in its own biosphere, if you will. So if you freeze it, then is it going to float higher? I mean, I'd like to know that because there's no more air. I wouldn't think that's my hypothesis that there's more air getting into it. Because it's in a closed.
Here, all the air bubbles are on the outside.
Right.
And in here, there's some air bubbles on the inside.
Right. So why would it do it, or would it do it? I have to freeze this balloon now. I got to freeze this balloon.
Yeah, write those down.
Write those down.
Right.
And here, this is a present.
See, the air bubbles are right there on the surface.
I'm gonna put it in my pocket now. I nearly always have a balloon in my pocket.
But there's none on the surface there.
Well, I didn't today.
So that's actually I would that's an observation I would make, and then I would see if that would wrap into a question. She was asking about seeing the air pockets out here, but not seeing
them in the ice. So is it maybe that what you're saying, that the air
the air bubbles freeze on the inside? Yeah, so the air is on the inside, which is why it goes higher.
That could be. So that's a good hypothesis. I would go with that hypothesis. I think that's actually because in a raft is the same way. If you have a raft that's losing air, the air goes, you know, the air that's left in the raft always wants to go above the water. So maybe that's exactly what it is that it floats better with the air distributed equally.
Yeah.
I'll go with that.